Want to run your own DNS server on Linux? In this video, I'll walk you through setting up a DNS server on an Ubuntu virtual machine using Bind 9, the most widely used DNS software. Whether you're a student, a system admin, or just curious about how DNS really works behind the scenes, this guide will help you understand the process step by step. Let's dive in and bring DNS to life on your Ubuntu VM. Here's the topology we will use. We have 3 Ubuntu VMs running Zorin OS, which is a user-friendly Linux distribution based on Ubuntu designed to make Linux accessible to users coming from Windows or Mac OS. It includes a desktop environment and is compatible with all Ubuntu repositories and commands. We have 3 VMs in 10.90.30 network. Linux A, from where we will verify to check if our DNS is working as configured. For Linux B, we will create a DNS entry. This is the VM Linux A will reach using FQDN. And Linux C is our DNS server. Let's first quickly verify they can talk to each other. So here are the 3 VMs. Linux A is 30.2. Linux B is 30.3. And Linux C, our DNS server, is 30.4. Let's quickly verify the reachability among them. As you can see, Linux A can reach the other 2 VMs. Let's now proceed and set up the DNS. The name server in etcresolve.conf file on Linux A points to our DNS server, which is 10.90.30.4. etcresolve.conf file is responsible for defining DNS client configuration. It tells Linux A that Linux C is the DNS servers to use when resolving domain names into IP addresses. So here's our Linux A VM. The etcresolve.conf file points to Linux C as the DNS server, 10.90.30.4. Let's now proceed and install the DNS package on Linux C VM. First, we run the sudo apt update, which updates your local list of available packages from all configured apt repositories. It ensures that we are installing the latest version of the software. Next, we install Bind 9 package, which provides the DNS server software. The -y flag automatically answers yes to any prompts during installation. We now have the DNS package successfully installed on our server. So now that we have the Bind 9 package successfully installed, let's quickly start the service and verify that it is running on our server. Next, we configure the name .conf.local file on the DNS server. This file in Bind is used to define the custom DNS zone that the server will manage. It is essentially where we declare our domains, or you can call them zones and link them to their corresponding zone data file. So this tells Bind that I am the authoritative master for the zone ztbpod30.com, and the DNS records for this zone are stored in this file. And finally, the forward zone file defined in the name.conf file we just saw. It defines how the host names under this domain are resolved to IP addresses. It defines the TTL, which is the default time to live in seconds, and this is the number of seconds in 7 days. Here's where we refer to the domain name ztbpod30.com. The start of authority record defines the primary name server and the admin contact. The serial is the version of the zone file. It increments whenever any changes are made. Refresh is when the secondary DNS checks for updates after 7 days. Retry tells failed refresh after 1 day. Expire means the zone becomes invalid after 28 days without refresh. Negative cache TTL is the time other DNS servers cache failed lookup, which is 7 days. So this specifies that the authoritative name server for the domain ztb.pod30.com is ns.ztbpod30.com, and here the A record for host to IP mapping, which tells that server1.ztbpod30.com maps to 10.90.30.3. So this zone file tells the DNS server that it's an authoritative for ztbpod30.com. This is a critical file for the DNS to function as it contains the host to IP mapping. With Bind9 service running and all the DNS configuration in place, let's now hop on to the fun part and verify the DNS. We'll first run the dig command, which is the DNS lookup tool. The header section here gives the status of the query. It shows that we made one query and we got the response back. The question section shows this is the server we queried, server1.ztbpod30.com. The answer section shows that the DNS server 10.90.30.4 successfully resolved the FQDN, server1.ztbpod30.com, and the IP address that it resolved to is 10.90.30.3. This shows that it took almost no time to resolve. Here's the DNS server that resolved the query running on UDP port 53. Now that we've confirmed through the dig lookup tool that the DNS server is correctly resolving host names, let's do the final validation. We'll verify that Linux A can reach Linux B using the FQDN instead of the IP address. As shown, Linux A successfully communicates with Linux B using the name server1.ztbpod30.com. This confirms that DNS resolution is working end-to-end, and our Bind9 DNS setup is fully functional. To recap, we first verified the reachability from Linux A to Linux B and C using IP. We saw Linux A sets the DNS name server pointing to 10.90.30.4, which is Linux C. We then installed the Bind9 package on the DNS server. After successful installation, we started the DNS Bind9 service and verified it's actively running. We modified the named conf local file on the DNS server, which points to the zone file. We saw the forward zone file in which the DNS server creates host to IP mapping for Linux B. Finally, we did the verification by first running the DNS lookup tool on Linux A. As a final verification, we saw Linux A was able to talk to Linux B using FQDN. This wraps up our guide on setting up a DNS server on a Ubuntu VM. I hope you find the walkthrough helpful and informative. If you enjoyed this video, don't forget to like, subscribe, and share for more hands-on content, configuration, and advanced security solutions. Thanks for watching, and see you in the next one.